All right, folks, I'm ready to get started. Welcome back, everyone. Welcome back to the end of our fourth week together. So it's been a month since we met. It's pretty nuts. We're a quarter of the way done with the semester. Almost at the end of the first part of the course. We have one more week to go, and then the first exam will be following that. So today we're going to cover Chapter 4, which is focused on individual and market demand, basically using our rational consumer choice model to get us to the individual, then a market demand, and kind of talk about a bunch of ancillary issues that kind of extend from that. So we'll talk about the effects of a price change on the consumer equilibrium, and then how that can get us to the individual demand. We'll talk about the effects of changes in income, and talk about how that can get us to another relationship between quantity demanded, and in this case, instead of price, is income. So the relationship between income and quantity demanded, which gives us information about how consumers view the good, whether normal or inferior. So basically, this chapter is meant to kind of expand like our understanding of like the various applications of the model, what kind of insights we can gain from sort of using it to explore other avenues. We're able to break down the effects of price changes into what are called the income and substitution effects of a price change. When a price changes in general, it has two effects on people. One is it causes them to substitute away from the good they're buying to some other good if the price goes up. And then the other one is that if you think of everything that we buy in real terms, in terms of like the value, if you think about our income as the value of everything that we can buy, so that's thinking of our income in real terms, then if the price of something goes up, then it will crowd out your ability to buy other things. So your real income goes down. So there's two effects of a price change. One is a substitution. What is the income effect? And we can use the rational consumer choice model framework to kind of break down how a change in price is affecting a consumer via the substitution or the income effect. And it has everything to do with that consumer's preferences, which are embodied in the curvature of the indifference curves. And I'll talk more about it when we get to it. So then we'll talk about getting from individual demand curves, which we can derive from changes in prices for like the individual consumer. Getting from there to the market demand, which is the demand curve we've been talking about in the competitive market model that we used in the last chapter. And then we'll talk about price elasticity of demand, the measure of how responsive demand is to changes in price and how we can measure that from demand. And then we'll talk about the relationship between elasticities and total revenue, and how elasticities tend to change along a demand curve, and how that will affect whether total revenues are increasing or decreasing as prices are changing. We'll basically look at the mechanics of that. So it's a lot of sort of like ancillary stuff, kind of to kind of branch us out from what we've been talking about, which is like demand, and then the mechanics behind demand, which was the last chapter, and now kind of like taking us to some other sort of related places that the models allow us to go, providing us deeper insights into the power of the models and the amount of information we can gain about prices in different markets from these simple relationships that we've been studying. So that'll finish up chapter 4. I've already opened up the homework for that one. I'll open up the mini paper as well. That'll probably be due at the end of next week. And then we're just going to cover chapter 6 next week. Chapter 6 has to do with information. So up until this point, we've assumed that everybody has all the information they need to make the right decisions, but in reality, that's not the case. Sometimes people don't have all the information they need, so therefore they need to kind of make calculations about how they should be going about things based on what could possibly happen using probabilities. And so we'll use a little bit of probability in the next chapter to kind of examine a few issues that are related to either the lack of information or the uh, the fact that in market transactions, different parties may have asymmetric information. Some parties may have information that others don't. So we'll just touch upon a few issues, and then that'll wrap up the first part of the course. I'll also actually talk about consumer surplus at the beginning of the first class next week as a sort of supplementary topic, which I think is covered in one of the appendices. I forget exactly where it's covered. I think it's covered in maybe even chapter 5, which is why I'm just covering kind of independently. You've covered consumer surplus before, the benefit that consumers gain from markets, right? There's an excess willingness to buy, a bunch of people that are willing to pay different amounts for the good. The market price is set by the equilibrium of the market. You have a lot of people in the market whose willingness to pay is above that. So the difference between an individual's willingness to pay, their reservation price, and the price they have to pay is their consumer surplus. And so we'll look at just being able to measure that as just a quick supplementary topic before we move into chapter 6 and finish off the first part of the course. Are there any questions about anything you want me to address before I move forward with today's material? Yeah. No, but we do have that one open paper submission option at the top for any chapter that you choose to write a paper on at any time throughout the semester. So that is a way to sort of make up for that. But again, like ideally, I know some of you have been writing papers already, which is great. You should be. You get it done sooner rather than later, folks. Don't wait till the last moment. If you have free time, like use it to think about these things. Write something, that makes sense, that'll get you like a good grade so that you can at least have that done before everything else starts hitting you from every direction it's about to happen right now. Like the first midterm period begins, right? And so just take advantage of those free times you have and make sure that you are at least trying to knock out the paper sooner rather than later. Yeah.
What do you want us to use secondary source for?
You mean just like outside source? Like we talked about last time, like bring in some outside information to sort of support your claim. Just any kind of outside information you bring in that's not related to the book, not related to the theory, just like some other source. So it could be anything. Just so that you do, take that extra step to kind of do a little bit of research to expand the analysis. Other questions? All right, then let's move forward. Individual market demand. So let's look at the effects of a price change on the consumer equilibrium from the rational consumer choice model that we studied the last week and a half. So again, imagine there's a consumer. Their optimal consumption point is the point where they are consuming a consumption bundle along their budget constraint, which means that they are exhausting their income, and they are choosing the consumption bundle that's going to make them the happiest, give them the highest level of utility, and so they're going to be consuming the consumption bundle at their equilibrium that is represented by the tangency point, the point of these two curves just touching, where the highest indifference curve, representing the curve that has consumption bundles that all yield the same level of utility, but have the highest utility of any indifference curve within the budget set. So that is the consumption bundle that makes the consumer the happiest and they can afford. The one that is at the intersection of the budget line and the highest indifference curve. A change in the price of a good will lead to a change in the equilibrium consumption bundle, as we know. So let's say initially we were at this equilibrium A, and let's say the price of the good has now gone down, right? So if the price of the good has gone down, if you think about the intercept, the horizontal intercept, it represents the most a consumer could buy if they chose this consumption bundle, and therefore only bought good X and 0 Y. So if the price of X goes down, that means you have your income divided by a lower number. That means you could buy more of that one thing that you only buy. And so therefore your horizontal intercept would move out and your budget line would pivot outwards. And so the consumer would now want to consume on their new budget line, which represents a larger opportunity set, a larger budget set, basically all the consumption bundles that can be bought now that the price has gone down for good X, and also makes them the happiest. So therefore, is tangent to the highest indifference curve. So now they can consume this consumption bundle, which is on this higher indifference curve, which corresponds to a higher level of utility, which means that all these consumption bundles make the consumer happier than any consumption bundle on any indifference curve closer to the origin. So that is the best the consumer can do now, given that the price of X has now decreased. So we see that that one has an increase in the quantity of X. So as the price went down, the quantity of X consumed goes up, reflecting the law of demand. But we also see that as the price of X went down, the quantity of Y went down as well, which means that X and Y are related as substitutes, right? As the price of one good goes down, people substitute away from the other good to the one good that's cheaper now. And so that's what that tells us there. Suppose the consumer's income is $120 a week, and the price of the composite good is, again, $1. So we're going to assume that this is the composite good here. We can use the information that we get from these changes in consumer equilibriums as prices change to construct the demand schedule for shelter if we're talking about the, the trade-off between the composite good and shelter, let's say. So here is what could potentially happen. So the figure shows 4 budget constraints that correspond to 4 different price changes of shelter. First, it was really expensive, $24, then $12, then $6, and $4. Just consecutively got lower and lower. The consumer has these indifference curves that are fairly steep, reflecting the fact that overall they value shelter quite a bit overall relative to income. So initially, based on their preferences embodied by the indifference curve and the budget line, they were consuming optimally here. The price of shelter went down to $12. That means that the budget line shifted out, and therefore the optimal consumption bundle was there. Again, price went down, budget line rotated out again, and got us to that new consumption bundle there. That's optimal for the consumer with that price of $6 in that case. And then finally, price went down to $4. Again, budget line rotates out, gets us to that new optimal consumption bundle. So if we track the equilibriums across these price changes, we derive what's called the price consumption curve. So holding income and the price of Y constant, the price consumption curve for a good X is a set of optimal bundles traced on an indifference map as the price of X varies. And we can use the price consumption curve then to derive the individual consumer's demand curve. So we can see here, plotting these combinations of quantity demanded and price as the price change, we can plot out the individual demand curve for this individual consumer that we are modeling via our rational consumer choice model, right? This is the consumer's preferences. This is how they respond to changes in the price of shelter. As it goes down, they consume more. And the nature of the interaction of the market rate of substitution, the rate at which the goods can be traded in markets due to prices in markets, which is embodied in the slope of the budget constraint, and the marginal rate of substitution, their own subjective rate that they're willing to trade off one good for another. The interaction of those as the price changes leads us to be able to plot these points, which now represent this individual's demand, overall demand for shelter as prices change. So we can use, again, this rational consumer choice model to get us to the individual demand of a consumer, and therefore we can link that information, the individual demand, to this decision framework, and therefore get more insights into demand and how prices change based on people's preferences and different prices in the market. We can also track what happens to that equilibrium with changes in income. So if you remember, here's just a standard budget constraint. When an income changes, the budget constraint will either shift out or in a parallel fashion because the prices aren't changing, so that relative price, the market rate of substitution, the rate at which goods can be traded in markets, which is embodied in the slope of the budget line, is not changing. Just the income itself, which is changing the opportunity set, the consumption opportunities for the consumer, embodied graphically as the triangle bounded by the budget line and the axes. So here we are at some initial equilibrium. Let's say the income goes up. That will shift the budget line out. As in the case of a price change, the exact location of the new equilibrium point will depend on the consumer's preferences, which again are embodied in the indifference curves, the shape of those indifference curves. This seems to be a fairly normal specification of those preferences, where they view both goods as just standard goods. The more, the better. So the income analog, the analogy to the price consumption curve here, is called the income consumption curve, or the ICC. And again, it tracks the optimal consumption choices as incomes change for this consumer. So again, based on the consumer's preferences and the changes in income, we see that the optimal equilibrium will shift outwards as of course, as the income shifts out. And what this is telling us, just from what we can see, is that as income goes up, we see that the quantity demanded of X is going up, so therefore it is considered a normal good by this consumer's preferences. But we also see that Y is also going up as the income goes up, which means that money is viewed as a normal good for the consumer as well. So again, this line that sort of tracks the locus of these equilibria is called the income consumption curve. So holding the prices of X and Y constant, the income consumption curve for a good X is the optimal bundles traced on an indifference map as income varies. And we can use that same information to plot what's called an angle curve, which is a relationship between income and quantity demanded. So the analog to the individual demand curve is, in the income domain, is the individual angle curve. So again, so here we have income and income on the y-axis and shelter on the x-axis. We see that we have a positive relationship here. So again, this is reflecting the fact that the consumer views this good as a normal good. So the angle curve is a curve that plots the relationship between the quantity of X consumed and income. The angle curve is linear, but it doesn't need to be. And again, you can use it to identify whether the consumer views the good as a normal or an inferior good, depending on whether the angle curve has a positive or a negative slope. So as income goes up, quantity demanded goes up for tenderloin steak, normal good. As income goes up, quantity demanded goes down of hamburger. Hamburger is viewed as an inferior good by this consumer. So again, the relationships between what choices are being made due to preferences, due to market rates of substitution, can provide us insights that can lead us to demand, and we can also link that back to like how the consumer views the good, whether normal and inferior. Which again, if you do market analysis and use statistical data to estimate demand curves, you can kind of back out these sort of important sort of nuggets of sub information from that data that you get in the market if you know the right approach. But the point here is to understand that all these things are connected and that these concepts are not just meant to torture you in economics courses. Like, there's a lot of application to them. Again, we're dealing with very simple cases in this class. Two goods. The world is more complicated than that. So in practice, the models used are more complicated. But as far as like the heart of these relationships, how they work, the logic that we presented here, like that is how those models work. So all the conclusions do extend to the more complicated cases. So again, a normal good is this one whose quantity demanded rises as income rises. An inferior good, one whose quantity demanded falls as income rises. All right, now let's look at the income and substitution effects of a price change. Again, like another important sort of offshoot of all this is that you can use the model to break down the effects of a price change into that substitution and income effect. that I talked about at the introduction. So suppose a consumer initially is at equilibrium at point A along the budget line connecting F and G. So suppose the price of good X increases. So the price of good X increase, that means the most of good X the consumer can buy has now decreased. That means the budget line will rotate inwards. So there are two things to notice about the change. First, since the budget set is smaller due to price increase, the consumer will be worse off after the price increase, right? The price has essentially caused the opportunity set of the consumer to become smaller. So again, that reflects the income effect. It reflects the fact that if you think of your income in terms of the value of everything you can buy, if the price of something goes up, the opportunities that you can of things that you can buy with your income shrink. And so that is what the rotating in of the budget line represents. The second is that the increase in the price of X leads to a budget line with a steeper slope. We know the slope of the budget line is equal to the ratio of the price of the good on the X-axis to the price of the good on the Y-axis. It's called the market rate of substitution or relative price. You can also think of it as the opportunity cost of buying more of X. You have to give up a certain number of Y, which is that number is given to you by the slope, right? If the slope is negative 1/2, that tells you that each additional unit of X requires half a unit of Y in exchange value in the market. So if the price goes up of X, then the price in the numerator is going to be higher. That means the slope is going to be higher. That means the market rate of substitution will be higher. That means that now it costs you more in exchange value to give up 1 unit of X. Like you need to be compensated with more of Y. So because of that, you know that your X good is now more expensive, and so if you live in this simple two good world, you are going to substitute away from the more expensive good to the less expensive good. So the two factors lead the consumer to move from the initial equilibrium point A to point C. So we can isolate the two effects of a price change to see how each effect individually alters consumer choice. So we can use the framework to kind of break down this effect of the price change. So let's ignore for a moment the fact that the price increase leads to a lower indifference curve. So let's ignore the fact that this happened by hypothetically giving this consumer some income to compensate them for the fact that the price has increased of X to the point that they can still consume on the old indifference curve. So they can now be as happy as they were before, hypothetically speaking, by being given this extra amount of income. So that would require giving them extra income. This red budget line represents that extra amount of income. It's a parallel shift of our new budget line. Again, embodying the new market rate of substitution due to the price change, but hypothetically adding income to the consumer. All right, so the budget line has the same slope as FH, but it implies a higher income than FH. Given this budget line, the consumer will achieve equilibrium at B. So before they were at A, but now that the price has changed, then we are in a situation where, so remember, at the old equilibrium, the marginal utility per dollar spent was equivalent across all goods. When the price of X went up, the marginal utility per dollar spent at this old equilibrium was greater for good Y than good X, because you're dividing the marginal utility of X by a bigger number, the price of X. So that means that now you're getting a smaller amount of marginal utility per dollar spent on X than on Y. That means the consumer would want to buy more of Y than on X, which means that they would consume less X and more Y, move along their indifference curve to this point here, where once again their marginal rate of substitution is equal to the slope of the budget line. So the movement from A to B is what we call the substitution effect. That component of the total effect of a price change that results from the associated change in the relative attractiveness of the goods. So It's a way to sort of just like zone in on like how much the consumer is just substituting away from good X to good Y as a result of good X becoming more expensive. Again, it reflects how the consumer will react to a different market rate of substitution. So considering the equilibrium at point A, again, we know that at point A, we had the marginal utilities per dollar spent to be equivalent across all goods. The substitution effect from the price change reflects the increase in relative prices, resulting in, again, this price being higher and therefore this being smaller at that old equilibrium. So therefore, the marginal utility per dollar spent being greater at the old equilibrium than this. But remember, as you consume more of something due to diminishing marginal utility, the extra amount of utility satisfaction you gain from consuming more units is less for each additional unit you consume, and therefore, as more Y is consumed, this will become smaller and smaller until these equilibrate again, which is why we do wind up at a new equilibrium there. All right. So anyway, so doing all that and understanding why this can reflect the substitution effect, we can now identify the other effect of a price change, which is the income effect. So taking back that income we gave, so essentially the substitution effect led us to go from A to B, which caused the reduction of consumption of good X to go from that initial amount X naught to XM. So the difference between these two is the substitution effect of a price increase. Now, if we take back that hypothetical budget that we gave the consumer, essentially shifting it to the new budget line that is the correct budget line due to the price change, now we can identify the income effect of a price change. So the income effect is that component of the total effect of a price change that results from the associated change in real purchasing power. So the reason why the consumer consumed even less X is now due to the income effect. Again, overall they felt poorer, so because of that, they wound up consuming less of X, but also less of Y. So here they were consuming more of Y due to the substitution effect. They actually increased Y, but due to the income effect, because they overall felt poorer, they bought less of everything. And so going from B to C, we see that from XM to X1, there was a further reduction in X, which again reflects the income effect of the price increase, but there was also a decrease in Y, which also reflects the effect of the price increase. So again, the model can allow us to identify both the substitution and the income effect, and you can get certain informations from that. So here, since X is a normal good, in this case, the reduction in income leads to a further reduction in the consumption of X. So going from B to C, we essentially took away income there, the real income, the real purchasing power there, which led to a decrease in the quantity demanded of good X. And so decrease in income, decrease in quantity demanded of good X means that the consumer views the good as a normal good. The total effect of a price increase, which is what we observe in the marketplace, is the movement from A to C. And with normal goods, substitution and income effect will move in the same direction. For consumers whose indifference curves have the conventional convex shape that we've been looking at, the substitution effect of a price increase will always reduce consumption of the good whose price increased. So for the standard consumer, not some really weird case, but just like a normal consumer that we've been studying with these kind of convex indifference curve, the substitution effect will always be negative when the price goes up and will always be positive when the price goes down. The income effect, though, can move in either direction, acting to offset the substitution effect in the case of an inferior good. So the income effect thus works in the opposite direction from the substitution effect for inferior goods, such as, let's say, hamburgers. So here we are initially at the optimal consumption bundle before a price increase. All of a sudden, the price of hamburgers has gone up. That means the budget line rotates inward to this one here. And the new optimal consumption point is at D, just given the nature of the consumer's preferences. Again, to identify the substitution effect, we shift out the new budget line to be tangent to the old indifference curve. And we see that from point A to C, we can now calculate what the substitution effect was of that price increase, meaning that because the price of hamburgers went up, they substituted away from hamburgers to, in this case, the composite good, meaning they just didn't buy hamburgers and just kept their money. So we see the substitution effect is going to result in quantity demanded to change in the negative direction, and it would be in the opposite direction as the price had decreased. But if we take away that hypothetical income and go back to our optimal new consumption bundle D, the actual result from the change in the market, we see that in this case, the quantity demanded of good X actually increased from this consumption bundle C to D, which means that the income effect moved in the opposite direction of the substitution effect. The decrease in income led to an increase in the quantity demanded of hamburger. And therefore, we know that the consumer views hamburgers as an inferior good because of that. And what, again, it also tells us is that for an inferior good, the income effect will offset the substitution effect. It will move in the opposite direction of the substitution effect when it comes to price changes. So just understand that. Understand the mechanics of that and like the relationships between the price changes and how you can identify the different effects, and then like how depending on whether the good is viewed as a normal or inferior good, you're going to have different directions of the income effect. In the most extreme case, you might have what's called a Giffen good, in which the consumers, the good that the consumer buys makes up such a large part of their income that the income effect, and they view the good as an inferior good, the income effect is so big in the opposite direction that it actually increases the quantity demanded overall when the price increases. So it actually violates the law of demand. This is a hypothetical case. It's in fact nearly impossible to find an example. I'll talk about the one example that's always referenced in these classes. So a Giffen good is one for which the quantity demanded rises as the price rises. So you have an upward sloping demand curve instead of your standard downward sloping demand curve. So given the substitution effect of a price increase is always to reduce the quantity purchased, the Giffen good must be one whose income effect completely offsets the substitution effect. The Giffen good must be an inferior good to the extent that the income effect is actually larger than the substitution effect. The much cited example was the potato during the Irish potato famine in the 19th century. The idea was that like potatoes were such a huge part of people's diets that when the price of potatoes started going up because of scarcity of potatoes, then essentially it started to crowd everything else out, and it resulted in them buying more and more potatoes. So potatoes, again, were a large part of poor people's diets. Many families responded to rising potato prices by cutting back on meat and other more expensive foods and buying even more potatoes. Or so the story goes. Like, it hasn't even been clearly established that this actually happened, but it is the one case where economists that like to imagine that Giffen goods actually exist will use to sort of justify their delusion. In reality, it doesn't actually exist, and it's more meant to highlight the nature of the relationship between a consumer, the good, whether they view it as a normal or inferior good, and how the income and the substitution effect play a big role in that, and how you could hypothetically have a situation where the income effect for an inferior good could completely outweigh the substitution effect. All right, now we talked about how we can derive the individual demand curves based on just changes in price, tracking the equilibria of the consumer. And now we're going to get from an individual demand to the market demand. First, I'll show it graphically, but then we'll do some mathematical problems. So to get the market demand curve, we do a horizontal summation across prices of all individual demand curves. So here's some individual demand curve that was derived from studying the preferences of this consumer and the interaction of those preferences with the market rate of substitution as prices change. We track the locus of those changes via the price consumption curve, derive this individual demand curve. Same thing for this one here. But for this one, obviously their preferences were different, such that at a price above $8, they were not willing to buy anything, and only below $8 were they willing to buy. To aggregate demand, we do a horizontal summation across prices. So we just consider a price, and then we look at how much quantity demanded is for each consumer at that price, add them together, and then get to the market demand at the price. So again, at $12, we see the quantity demanded for this one is $2. For this one, nothing. So we're going to get that at $12, 2 units. At $8, quantity demanded is 4. 8 here, 0. So it's going to be 4 at $8 again. But then we're going to get a kink in this market demand curve because, again, this the second consumer, doesn't buy anything above the $8. So above the $8, the market demand is just the demand of this one consumer here. But beyond that, we combine the quantity demanded by the different consumers at the price that we're considering. So at $4, this consumer will buy 6 units. This consumer will buy 2 units. And so quantity demanded at $4 for the market will be the sum of those two, which is equal to, in this case, 8 units at 4. And so that's how we get to the market demand curve. We do a horizontal summation across prices, which means that we're adding quantities. And that's going to be important when we're dealing with the math to get to the market demand. So again, at $4, 6 plus 2 equals 8. So it's carried out the same way whether there are only 2 consumers or in the market or there's many millions. So when using the algebraic approach to aggregating demand, a common error is to add individual demand curves vertically instead of horizontally, which the following example will elucidate. So remember, as we see the demand curves plotted, we are actually looking at the inverse demand function because price is a function of quantity. But we need to add across quantities. In order to do that, we need to derive our demand functions and then add those together to be able to aggregate demand. So here's an example. Smith and Jones are the only consumers in the market for beech saplings, which is a plant in a small town in Vermont. Their inverse demand functions are given by P equals 30 minus 2J and P equals 30 minus QS for Jones and Smith. So quantity demanded by Jones and Smith respectively. So again, this is who is this? This is Jones. This is Smith. And again, you do horizontal summation to get to the market demand curve. So we're trying to derive this mathematical relationship from these. So the question is, what is the market demand for beech saplings in their town? All right, so when we add demand curves horizontally, we're adding quantities, not prices. So it's necessary first to convert the individual inverse demand functions into their demand function forms before adding them together. So here we'll take Jim's and we'll again solve for Q in terms of P to turn our inverse demand function into a demand function where quantity is a function of price. So I'm going to subtract 30 from both sides here, divide both sides by -2, and that gets me to Jones's demand function to be 15 minus 1/2 P. And then for Sal, or whatever his name is, we are going to, again, go from his inverse demand function to his demand function. So again, just do a little bit of algebraic manipulation. We're going to subtract 30 from both sides, divide both sides by -3. And that's going to get me to 10 minus 1/3 P as Sal's demand function. Now we can add them together. So if the quantity demand in the market is denoted by Q, we have Q is going to equal the sum of the two quantities of the two individual consumers, which means we're just going to add their demand functions together. So we have 15 minus 1/2 P, which is Jim's, plus Sal's demand function. And so if we add those together, we get 10 plus 15 equals 25. And then we got to get the common factor between these two fractions, which is equal to 6. So here we've got, common denominator. So here we've got 2 goes into 6 3 times, so you got 3 6s, and then this is 2 6s, so that's going to equal 5 6s for the price coefficient, the slope of the demand function. And now we need to solve back for P to get back to that inverse demand function, which will represent the equation for this line, the market demand curve. So just doing again a little bit of mathematics, algebra to solve for P in terms of Q. We subtract 25 from both sides, and then we multiply both sides by 6/5, negative 6/5, and that's going to get us to the market demand curve to equal 30 minus 6/5 Q. So that's how you go from the individual demands to the market demand mathematically. You need to solve for the demand functions first, then add them together. And if you're looking to put them back into a inverse demand function for the market, you need to once again solve for P in terms of Q. So that's the inverse market demand function. This is verified by the figure below. Here's our intercept of 30, and it's got a slope of 6/5 there. The common pitfall is to add the demand functions as originally stated and then solve for P in terms of Q, which is a problem. You shouldn't do that. So doing that would yield, so there's our, this is the result of adding these two together, which again, in this case, yields a much bigger slope, which is incorrect. That's not the market demand curve we're looking for. So just make sure that you don't fall into that trap. The horizontal sum of individual consumers' demands in market demand has a simple form when the consumers in the market are identical. So if, let's say, you have some representative consumer and they have an individual demand, if that is the case, and then there's n consumers that all have that same inverse demand function, then here is our inverse demand function for the individual consumer I. Again, solving for Q in terms of P will get us to this demand function for that individual consumer. Then the market demand is the sum of the quantity demanded by each of the n consumers. So now you can just, instead of adding n amounts of the same equation, you just multiply it by n, by however many consumers there are that have that individual market, individual demand function. So Q equals n times Qi. So n times this function there, which winds up equaling this. And then you solve back for your market demand curve by solving for P in terms of Q. By doing that, you can see that this form is fairly similar to the initial form that we started with for this individual consumer that's been aggregated across n identical consumers, and that is that the inverse demand function for this individual consumer is basically the market demand curve for all the representative consumers, with just the slope being divided by the number of consumers. So that's just a shortcut if you remember it, but you don't need to remember it. You can just derive it by doing the math. So inverse market demand function there. Again, inverse market demand function is the individual market demand function of identical consumers with the slope divided by n. The intuition is that each 1 unit demanded by the market is 1 divided by n unit for each consumer. So essentially, by including that there, you are dividing up each unit by all the consumers, the quantity by all the consumers in the market. All right, let's do a practice problem, aggregating individual demand, parts 1 through 3. So there's 10,000 poor people and 40,000 middle-class people in Genosha. So you have 2 different types of people in this place. Monthly demand for restaurant meals can be described by the following individual inverse demand functions. So you've got P equals 30 minus 10Q for poor folk. And middle-class folks are P equals 69 minus 5Q. What is total monthly demand from poor people at a price of $20 for restaurant meals? So how can we figure that out? 20, right? Where? Which one? This one here? All right, for poor people. All right. So you want me to plug in 20 bucks into the poor person's individual inverse demand function? I will do that. And I'm sorry, no. We're looking, okay, wait, what is total monthly demand from poor people at a price of $20 for a restaurant? Okay, we're looking for total monthly demand. Sorry, I got lost for a second. Total monthly demand from poor people. We know that there's 10,000 poor people, and this is an individual person. So we need to aggregate this across the 10,000 folks first before we are able to do, able to just plug in the $20, right? So we can take the shortcut, but I prefer the math because shortcuts, sometimes if you don't remember them properly, you'll forget, and you also don't really know what's happening behind the scenes. So again, you want to get this into the demand function form. So just move 30 to the left, divide, I just switched the sides there. Divide both sides by -10, and that gets us to the poor person's demand function to be Q equals 3 times 1 over 10p. And now how can I aggregate this across 10,000 people that have the same demand function? Not plug in. Multiply by 10,000, right? Multiply this individual person's demand now by 10,000 people. They're all the same. You're essentially then adding, 10,000 of these together, which is the same as just multiplying it by 10,000. Remember, you're doing a horizontal summation across prices. You're adding quantities. But there's 10,000 quantities you're adding, and they're all the same, so you can just multiply the equation by 10,000 to get to that market demand function. All right, so poor population demand function, again, N times Q. So multiplying this by 10,000 gets us to 30,000 minus 1,000p. And if we plug in a price of $20, we see that the poor person demand is going to equal, in this case, 10,000 meals. 10,000 restaurant meals at a price of $20. What is the total demand from all people at that $20 meal price? All right, so now we need to figure out the middle class folks, right? So we've got the middle class demand as well. We need to turn that into our demand function. This is our inverse demand function for middle class folks. So we need to turn that into a demand function. We need to multiply by 40,000 to get the population demand for the middle class population, and then figure out how much they're willing to buy at that price of $20, and then add them together. So the poor folk, again, 30,000 minus 1,000p. Inverse demand function for middle class folks is this guy. So we need to, again, solve for Q in terms of P to get the demand function. So subtract this from both sides. And then I switch the sides there, and then I divide both sides by 5, which gets me to this demand function for middle class folks. Now what do I do to aggregate it across all middle class people? Multiply by 40,000, right? So I'm going to multiply by 40,000. So the middle class demand function is then equal to 552,000 minus 8,000p. If we plug in $20 there, we find out that middle class folks are willing to buy 392,000 meals at a price of $20. So, so the total demand is equal to demand by middle class people above a price of 30, and the sum of both demand functions at a price of 30. So remember, if we're going to aggregate these guys, we got to take into account the fact that above a price of 30, the individual poor folks aren't willing to buy anything. And so above a price of 30, the market demand is going to be just the middle class demand from $69 to 30. And then beyond that is where the combined demand of the market will include all of their demand. But in this case, we're considering a price of $20, which falls within the $30 limit that poor people are willing to pay. So therefore, we would consider the aggregated demand in this case. So as far as just kind of setting up the overall market demand for the entire market in this town, for a price greater than or equal to 30, the demand function is going to be just the middle class demand. For a price less than 30, the demand function is going to be the sum of the two. So we're going to add these two functions together for prices less than 30. So that's going to be, again, 552,000 plus 30,000, and then negative 8,000p minus 1,000p, which will get us to 582,000 minus 9,000p for the Q total. So in this particular example, to get to the market demand, we need to specify the fact that it's going to be a piecewise defined function, meaning that over some range of price, in this case, price greater than or equal to 30, this will be the demand function. For a price less than 30, this will be the demand function. And if we plug in 20 bucks there, we get 402, which is the sum of the amounts of the two we're willing to buy. What is the total demand from all people at a price of $49? So how can we get that? Into this first equation here, right? Because poor people aren't willing to buy anything at $49, so we're not going to use the aggregated demand, market demand. We're just going to use the market demand that reflects the market demand above a price of $30. So we're going to plug in $49 into our middle class demand function to figure out that 160,000 meals will be demanded at a price of $49 in this market. All right, so make sure that you understand how to aggregate demand, whether within a few individuals or populations of individuals, and to keep track of the fact that there might be like a piecewise defined condition that needs to be set up between different sections of the market. All right, let's move on to price elasticity of demand. Suppose some variable, such as the price of a product, increased by 10%. What would happen to the quantity demanded of the good? Well, the price elasticity of demand can give us an idea of that. The primary tool used to determine the magnitude of such a change is elasticity analysis. Elasticity in general does not need to be a specific economic concept. It's merely a relation between two variables. How sensitive is a change in one variable to changes in the other variable? So elasticity is a measure of the responsiveness of one variable to changes in another variable. It's the percent change in one variable that arises due to a given percent change in another variable. So let's say we're talking about, in very general terms, the elasticity of your grade with respect to how much you're willing to study. So how sensitive is your grade to changes in your studying? So we can look at the percent change in your grade that will result from a given percent change in the amount you study. Percent change is represented by a triangle there. So the elasticity of your grade with respect to studying is the ratio of the percent change in your grade with respect to the percent change in the amount you study. Percent change in your grade is the change in your grade divided by the starting grade times 100. And the percent change in your studying is the change in your studying with respect to the starting point of your studying times 100. And so we know that the elasticity of your grade with respect to studying is the ratio of these two expressions. And so if we plug these expressions in for our elasticity, the hundreds will drop out because it's 100 over 100. You're left with the change in your grade over your grade divided by the change in the studying over your studying. You have a ratio divided by a ratio, which is equivalent to a ratio times the reciprocal of the denominator ratio. So by the commutative property of multiplication, we can move some things around here. So we wind up with this expression here. So basically, we can express the elasticity of your grade with respect to studying as a product of the slope of the relationship between your grade and the amount you study times the amount you study over your grade. In calculus, the change in G over the change in S can be approximated by the derivative, the slope of a curve. So we can write the elasticity equation as the change in G over the change in S, the derivative of the grade function with respect to studying times the amount you study over your grade. So that's just the mathematics of how we can express elasticity in a different way than just a ratio of percentages. Now let's turn to what's important for this class, which is the price elasticity of demand. How responsive quantity demanded is to changes in price. So an analytical tool of central importance for market analysis is the price elasticity of demand. It's the percent change in the quantity of a good demanded that results from a 1% change in its price. Here is the standard specification of the elasticity of the price elasticity of demand, which if we use the same math we just used, we can derive this equivalent expression here, which basically says that elasticity can be expressed as a product of the slope of the demand function, right? Quantity as a function of price times the price over quantity. So slope of the demand function times the price over quantity. At any given point, we can analyze what the elasticity is by just taking the slope of the inverse demand, slope of the demand function times the price or quantity. Another thing we could do is just take the slope of the inverse demand function, which would be 1 over, so the slope of the demand function is the inverse of the slope of the inverse demand function. So if you have the slope of the demand function and you just flip it around, then you're going to get the slope of the inverse demand function. So 1 over that reciprocal will get us back to the demand function. So this is equivalent to this, essentially. So let's say you have a demand function in the standard form reflecting what you see on graphs. Then you can just put 1 over the slope of that function into this equation times the price and quantity at the point that you're considering to figure out what the elasticity of demand is at that point. So this is 1 over dp dq, the slope of the inverse demand function. As far as the magnitudes go and what they tell us, if the price elasticity of demand is between 0 and 1 in absolute value, then we say that we have inelastic demand. If the price elasticity of demand is between 1 and infinity, greater than 1 in absolute value, then we say that we have elastic demand. And that means that quantity demanded is very responsive to changes in price versus inelastic demand. That means that quantity demanded is very unresponsive to changes in price, right? So you got to consider goods like life-saving medicine are going to be inelastic with respect to changes in price versus something like your housing that will be very elastic with respect to changes in price because again, it makes up a large part of your income. So if your housing doubles in price, you're gonna quickly find an alternative to that. So demand is very elastic for housing, but very inelastic for like life-saving medicine, let's say. The demand for a good is said to be unit elastic if its price elasticity is equal to 1 in absolute value. When the market demand curve is linear, several properties of the price elasticity quickly become apparent. The first is that the price elasticity is different at every point along the demand curve. So the slope of a linear demand curve is constant. So the slope of this line is not changing. But as we're moving along, the price and quantity are changing. So they take different values at every point along the demand curve, which means that the elasticity will be different along a demand curve. As we approach the vertical intercept, this will approach infinity because quantity will approach 0. As you divide a number by a number that's getting smaller and smaller and smaller, that number gets bigger and bigger and bigger, and that's why we say that as we approach 0, this value will approach infinity, and so then demand will get as elastic as possible. So as price gets higher, demand tends to be elastic. If it declines steadily as we move downward along the demand curve, it declines steadily as we move downward along the demand curve, right? Price decreases and quantity gets bigger, and so elasticity will get smaller, and therefore along lower prices along a demand curve, the price elasticity of demand will be inelastic as we get closer to the horizontal intercept. And therefore, there has to be a point at which the switch happens, and therefore it will be the point at which price is unit elastic, right? A second property of the demand elasticity is that it's never positive because we're talking about Again, the law of demand: as price goes up, quantity demanded goes down. As quantity demanded goes, as price goes up, quantity demanded goes down. The other way around. I skipped something there. As price goes down, quantity demanded goes up. All right. So there's an inverse relation between the variables, and so this will always be negative. So you don't doesn't matter if you put that negative sign in front of the price elasticity of demand, because we know that by its very nature, this measure will always be negative. So it's not, unless it's a given good, which doesn't exist. So therefore, it will always be negative. A third property is that along a straight line demand curve, elasticity will be inversely related to the slope of the inverse demand function. So let's say the slope of the inverse demand function gets bigger. That means the overall number will get smaller. So for steeper demand functions, overall, we're going to get more inelastic demand. So the elasticity doesn't just change along the curve. The curve itself tells us something about how elastic demand is in a market. The steeper the demand is, the more inelastic demand is. The flatter the demand curve is, meaning that the slope is smaller, so you're dividing 1 by a smaller number, this gets bigger, so elasticity becomes bigger. So the flatter the slope of the demand curve, the overall more elastic demand you will find in a market. The two polar cases of demand elasticity are shown in the figure below. These are the extreme ends of the possible elasticity spectrum. You can have perfectly inelastic demand with the case of life-saving medicines. People, like, if you remember that recently in the news, they were talking about that EpiPen, which is like that injection that people use when they have that allergy to peanuts. So they eat peanuts, sometimes they can die. It's pretty severe. That EpiPen is like their emergency way of kind of like counteracting that effect. The supplier of this EpiPen like raised the price by like 1,200% or something. And there was a big uproar about it. Whether or not that actually affected the price is not important, because these people that depend on this pen to save their lives will pay for the pen no matter what. And so you can imagine that the demand for that EpiPen is perfectly inelastic. So therefore, you will have a vertical line to represent that kind of demand, where the elasticity will be equal to 0 in that case. Yeah. Exactly, right. There will be a point at which the curve will be perfectly unit elastic, when it's going from inelastic, steep, to flatter, elastic. Yeah. And then, of course, we have the other extreme end of the elastic spectrum, in which you can have perfectly elastic demand, in which the demand curve will be a horizontal line. It's the case in perfectly competitive markets, which we'll talk about later in the course, where you have an infinite amount of buyer, which again is reflected by the market model we've been talking about. That is a model of a perfectly competitive market. The individual firm is incapable of affecting prices in those markets, because we assume that there's an infinite amount of sellers. Everybody's selling the same thing. There's so much competition that if anybody tries to raise the price by even a penny, quantity demanded goes down to 0 instantly, because there's so many other substitutes. And so in that circumstance, you have perfectly elastic demand, and the demand curve is represented by a horizontal line. All right, so we've got perfectly elastic. So demand curves are called perfectly elastic, and that will be an important factor in the study of competitive firm behavior. The vertical demand curve has a price elasticity everywhere equal to 0. And these curves are called perfectly inelastic. All right, so sometimes it's questioned, like, why do we need this elasticity measure? We can kind of figure out from just like the slope of the demand curves, like how people are responding to changes in price. Other things equal, we know the quantity demanded of a good with a steep demand curve will be less responsive to changes in price with one with a less steep demand curve. Since the slope of the demand curve is much simpler to calculate than its elasticity, it's natural to ask, why bother with elasticity? Well, one reason is that the slope of the demand curve is sensitive to the units we use to measure price and quantity, while elasticity is not. So here we have price per gallon versus price per ounce, and we see that the slopes are significantly different, given that we are, I think this is gasoline we're measuring here. So if we're just using the slope to kind of measure how sensitive people are to changes in price, that is particular to the units that are being used, and elasticity is not. It's just looking at percent changes, and so that is more of a universal measure. It will be the same across both of these specifications of how we're measuring the amount of the good that's being transacted. All right, so what determines how elastic demand is? There's 4 factors that mainly influence the price elasticity of demand for a product. Substitution possibilities. Is there a lot of options for people, or are there not a lot of options for people? If, like that EpiPen, there aren't any options at all, demand will be perfectly inelastic. But if you have a ton of options, like for aspirin, there's so many manufacturers of aspirin, anybody can produce aspirin. The formula is public domain knowledge, so under that circumstance, there's an infinite amount of substitutes, and therefore demand is going to be perfectly elastic in that case. And then so the cases in between will depend on whether or not there's a lot of substitutes or there are not a lot of substitutes. So in general, the absolute value of price elasticity will rise with the availability of attractive substitutes. Budget share, I mentioned housing. So if housing is changing in price, that usually makes up a huge part of people's income, at least half generally. And so if the price of housing doubles, then they're going to respond pretty quickly to that. They're going to want to move or do something to sort of just respond to the price change, versus salt. Salt is nothing, right? It's $1, $2, whatever. If the price were to double tomorrow, you like salt a lot, you're going to keep buying that same amount of salt. You're not really going to respond to changes in the price of salt. And salt is not a huge part of people's budgets, and so as a result of that, people won't be very responsive. Demand will be inelastic for salt, which is a small part of a budget, versus more elastic for housing, which is a large part of the budget. The direction of the income effect. Remember, the income effect moves in the same direction as the substitution effect for a normal good, and in the opposite direction for an inferior good. So the direction of the income effect tells us whether it will offset or reinforce the substitution effect. A normal good will have a higher price elasticity than an inferior good, other things equal, because the income effect reinforces the substitution effect for a normal good, but offsets it for an inferior good, right? So we see that quantity demanded will respond less in the case of an inferior good because the effects will move in the opposite direction. And of course, time. If people have time to search out alternatives, then demand will be more responsive later on, in the future, however long that is, versus in the present when the price changes immediately. So demand tends to be more inelastic in the short run versus the long run, however you want to define those time periods. All right, let's do one last practice problem and then call it a week. So again, we're dealing with the same example from before, where there's 10,000 poor people and 40,000 middle-class people in Genosha. Monthly demand for the 2 different types of folks, poor and middle-class people, are as follows. We looked at what the overall market demand, the demand functions look like for the total, and it's a piecewise defined one. So the question is, what is the elasticity of total demand at a price of $20? Use the right sign. So how can we figure out what the total demand is at a price of $20? First of all, we're going to look at this function or this function. The first one or the second one? The second one, right? Because $20 does fall within the poor person's willingness to pay, and thus the market demand function is going to be the one we're going to use. What piece of information can we get from this to measure the elasticity of demand? The slope, right? The slope of the demand function, right? The elasticity of demand is equal to the slope of the demand function times the price and the quantity, right? So we've got the slope. What is it? Is it 8,000 feet? Negative 9,000. Negative 9,000. Remember, we're dealing with $20, so it's going to fall within the entire range, but I know you know what you're talking about. All right, so negative 9,000 is the slope. What else? What other information do we have to figure out the elasticity? We have the price is 20, so what do we need? So how do we get that? Plug in the 20 to get that quantity, right? All right, so here is our elasticity. we just take the slope, negative 9,000, and we're going to plug in the quantity at price, which winds up being 402,000, something we figured out earlier in the problem. And so now we just plug everything in and multiply and get the elasticity of demand. So do this in your head, and I'm sure you're going to calculate it to be negative 0.447. So how do we describe this elasticity? Inelastic, right? It's between 0 and 1 in absolute value, right? If it's between 0 and 1 in absolute value, we say that we have inelastic demand. If it's greater than 1 in absolute value, we say we have elastic demand. And if it's exactly equal to 1, we say we have unit elastic demand. Unit elastic demand. All right. We already answered that question. We have inelastic demand. All right. So lastly, let's look at the relationship between elasticity and total revenue. So why does it matter whether demand is unit elastic, inelastic, or elastic? One important use is that the classification predicts how changes in the price of a good will affect the total revenue earned by producers from the sale of that good. So total revenue is the total value of or sales of a good or service. It's equal to the price multiplied by the quantity sold. Revenue equals price times quantity. In the case of a linear demand function, total revenue is at its maximum where demand is unit elastic. So over the inelastic range of demand, when prices are low, then over that range, if you were to raise the price, so let's say you were at a low price of $1 and you raised it to $4, then that would increase the total revenues. But over the elastic portion of demand, over the high price range, if you were to raise the price, because demand is elastic, that would actually lower total revenues. And total revenues are at their maximum at the point where the switch happens, where demand is unit elastic. The reason for this relationship between elasticity, demand, and total revenue is due to two effects that occur to demand when a price changes. One is the quantity effect. So let's say we're initially at this point, 90 cents corresponding to 1,100 toll crossings. This is a toll crossing market. So price times quantity is the revenue. If the city raises the toll to $1.10, then you're going to have people that are no longer going to purchase toll crossings. So we're going to lose that 90 cents they were charging times, in this case, 200 people. So there's going to be a quantity effect, which is going to reduce the revenue as a result of raising the price. But of course, there's going to be also a price effect, an increase in revenue from those still willing to buy in the market at the higher price. So that 20 cents times 900 is going to be the price effect. So depending on whether the price effect or the quantity effect is bigger is what will affect total revenue, either increase it or decrease it. When you raise the price and the price effect is greater than the quantity effect, then in that case, you're going to get an increase in total revenue, and that's over the inelastic range. And over the elastic range, the quantity effect outweighs the price effect, meaning you lose a lot more revenues from people not buying than you gain from raising the price, which then tends to lower revenues as you raise prices over the elastic range of demand. So over here, the price effect outweighs the quantity effect. Here, the quantity effect outweighs the price effect. Finally, let's just do this last problem. I have 2 minutes. If it takes me 3, I hope you'll give me that minute. Suppose that the demand for crossing the Golden Gate Bridge is given by the demand function, 10,000 minus 1,000 P. If the toll is $2, how much revenue is collected? What's revenue? Price times quantity, right? So we've got price, we need a quantity, plugging in price. We're going to get that quantity, in this case, of 8,000. I'm sorry, quantity of 8,000 multiplied by price, which will get us a revenue of 16,000. So revenue is price times quantity. Remember, I'm going to go quick, but it's being recorded. Go back, practice it. They're called practice problems for a reason. You have to practice them. What is the price elasticity of demand at this point? So what can we get from this to figure that out? Slope of the demand function, negative. Oh, that was me. I was being rude to myself. All right, negative 1,000 is the slope. We've got a price, which is 16,000. We've got a quantity. I'm sorry, 16,000 is a quantity. Price is $2. So we plug in the price. We got the quantity, which is 8,000. And we've got a negative 1,000. Yeah, the quantity was 8,000. That's 16,000 was revenue, sorry. I'm going fast. I'm messing up. Sorry, but you know what I'm talking about. Anyway, so the price elasticity of demand in this case is going to be negative 0.25. So demand is what? Inelastic. Demand is inelastic because it's between 0 and 1 in absolute value. Could the bridge authorities increase their revenues by raising or lowering their price? Demand is inelastic. Should they raise or lower their price to increase their revenue? They should raise their price. Inelastic range of demand means that that in order to raise revenues, they need to increase their price, right? All right, so they're going to be over this range here, which means that by raising the price, they will increase the revenue. So make sure you know the relationship between elasticity and total revenue to answer questions like that. Finally, the red and white lines, a ferry service which competes with the Golden Gate Bridge, began operating hovercrafts, which made commuting by ferry much more convenient. How would this affect the elasticity of demand for the Golden Gate Bridge? It would increase because now you're adding a new substitute, right? There's another substitute, so now demand becomes more elastic because of it. All right. We're done, folks. Congratulations. We're done with this chapter. I already opened up the homework. I'll open up the mini paper middle of next week. We have one more chapter to go. Get caught up this weekend. Make sure you know everything. You don't want to learn stuff the following weekend before the exam. Just get it all down now, okay? I want you to do well in this class. I'll see you next Tuesday.